Our second paper is called VAPLI, Novel Visual Abstraction from Protein-Lipid Interactions by Naif, Alharbi, Matthieu, Chavant, Micheal, Krone, Laramee, and Naif is given.
Hi everyone, my name is Naif Alharbi. In this presentation, I will give you an overview of our work by briefly describing the dataset and the problem and its solution. We work on membrane simulation that obtained from molecular dynamic simulation data software. Our dataset represents the dynamic of two types of molecules, protein and lipid. During the dynamic of the molecules, they interact with each other each time step. We try to get insights into the interaction between these molecules. If we think about the data set itself, it's nothing but the positions of the particles of the molecules when they move over the time. And it needs to be represented in some way. The common way the molecule are represented is using the symbol sphere, like the left image, or by complex surfaces, like the right image. If we have a close view and see this snapshot, we can see the whole system and how the protein and lipid interact with each other. This is the motivation behind our work. And this, on the right side, you see the image that represents our solution. We contribute by this work, which is the first work that focuses on the space between the molecule by defining an abstract protein interaction space. Also, we provide fast GPU based method to project the result on the abstract space or the cylinder. Our dataset contains 256 protein. Each protein involves about 300 particles. Also, 20,000 lipid molecule. Each lipid contains of 13 particles. In total, we got more than 300,000 particles interact during about 2,000 time step. Here we can see the structure of the protein and the structure of the lipid types. Our design, we first utilizing the principal component analysis to get the configuration of the space by finding the eigenvectors, which the base of our space, and the eigenvalues that define the radius and the height of the space. If you think about the system, what you see now is the membranes. The green represent the lipid particle, and the yellow bodies are the protein. Why did we choose the cylinder? If you think about this picture, you try to replace every protein by the cylinder, so it's cut through the membranes. By this way, when the flow of the lipid move surrounding the protein surface will capture the interaction between the flow of the lipid and the surface of the cylinder. By this way, as you can imagine, it's much simpler than using the traditional surfaces. How the solution enhanced the performance? We utilized two types of tests to test. The first test, if any lipid particle cross the boundary of the abstract space, we capture that particle and consider this particle are going to have more interaction with the particles of the protein. Second test, we take that particle and test that particle against all the protein particles. Also, this way we enhance the visualization. In this image, you see the Naif approach, which represents each protein by sphere, and try to encode the interaction by color. In the second image, you can see how the abstract space, which the cylinder enhanced the visualization. This video will give you an overview of the solution. This is the simple way to visualize the data set. The yellow particles represent the protein, and the green and the brown represent the lipid, and their color change based on the interaction. Here we use our solution, replace the protein by its abstract space. Each tile encodes the interaction between the lipid and the proteins at that tile. Focus and context can be used also with the visualization to get information about the lipid itself. Now we can see when the abstract capture the interaction, the color of the lipid will change to blue as soon as it interacts with the space. and the tile that has the interaction, receive the interaction, map the color to the number of interaction. Our future work, we are going to benefit from the idea of the property of the cylinder by projection the surface of the cylinder from the 2D into 2D to get insight into the analysis of the interaction. Any questions?